Hello everyone and welcome. Today I'm going to do something a little bit non-standard. I'm going to make a tutorial for you guys. I was working through Tomahawk Tower Defense and trying to figure out how to clamp our camera on the map, and there really isn't a good published solution on how to do it dynamically, so I went ahead and built one out. And I want to share that knowledge with you guys so no one else has to struggle through it. So without further ado, let's jump in. Alright, so first we're going to start out with an empty project, empty scene, and we're going to drop a couple planes in there because we'll use those to test out our camera. So we'll rename one to top, one to bottom, and we'll go ahead and drop in some materials for those so that we can tell them apart in the scene. Make a top, make a bottom, bottom. Now for the bottom one, we'll just make it a nice blue, so that'll pop real nice against the background. And we'll go ahead and assign that value, and we'll set the size of the bottom one while we're here. So for the bottom, we're going to drop it down one tick, and then we're going to scale it up to a 3x3 plane so that it extrudes past the edge of the top plane. At this time, I also assigned the bottom plane the tag BG plane, which is super important. Now for the top, we're going to go ahead and have a little bit of fun with it. We're going to slap down the Maximus Games logo on it. So we'll go ahead and drag the Maximus Games no text image file onto the albedo and drop the material onto the plane. Now let's set up our camera. Now we'll go ahead and drag it up, pull it back, set the rotation to 65. 65, and drag that into place so it looks real nice over our planes. That looks about right. Okay, reset our top, looks real good. Now let's go ahead and add the most important part, and the part you've all been waiting for, the camera controller. Open that up in Visual Studio. Alright. So, first things first, we're going to go ahead and clear out all that stuff and set up our variables. We need a public float pan speed, public float pan border thickness. That's going to determine how far from the edges you have to move your mouse to make the screen pan. Then public float scroll speed, public float min y, and public float max y. Sweet. Now let's pull up an update. And the function we're going to first write is lateral movement. So move the camera up, down, left, right around the scene. So private void lateral movement. Now if input dot get key W or input dot mouse position, come on autocorrect, mouse position dot Y is greater than or equal to screen dot height minus pan border thickness times screen dot height. So this will, if you press W or if you bring your mouse to the top of the screen, will pan you upwards. So vector 3 movement is vector 3 dot forward times pan speed times time dot delta time to normalize it Now that should work with letter W if check valid move transform dot position plus movement. And then you're going to transform dot translate the movement in world space, space dot world space. Now we're going to copy this out 3 more times because we need WASD, one for each direction, and we'll go ahead and set these all up. I should just change these values, change some signs. That looks good. Negative. Looks good. A, X. Should be nothing there. Width. Sign. Got a D, X, width, and that should be right. Should be good on all of our directions. Now I'll go ahead and write up a frame for check valid move real quick so that we can test out that we put in all those values correctly. So do private bool, check valid move, vector 3, new position, and we're just going to go ahead and return true out of that. Now hit save, jump back over to Unity, let's hit play and see if it works. And it's not moving. We didn't actually set our values yet, I don't think. Yep, didn't set our values. So go on in there, set those, call that 15, 0.025, 1, 5, and 12. That should be good. Now let's test it out. Alright, there we go. So now you can move around, but as you can see, we can kind of scroll out into no man's land and scroll way further than we should and wind up losing the map altogether. So this part is going to clamp it down by writing out this check valid move script. Let's take out this random bit and set up a nice framework. So bool valid move, we're going to start by assuming that it's not a valid move. Now we're going to use raycasts to determine if it's a valid move. So we're going to make this raycast hit as our variable to hold our hit pin. Then we're going to go physics dot raycast. We want our starting position to be the new position of the ray. We want it to go forward along the blue axes off our camera. And then we want the output to go into hit. Then if there's a hit, so real quick, looking at how it works, it's basically drawing a line out from that blue axis on the camera and detecting if it hits anything. So as it should hit our dragon canvas. Now coming back in, if hit dot collider dot tag, this is where it came in earlier, where we needed to tag our background canvas. So now if the tag is not background plane, we'll return that it is a valid move. But if that move would have put us on the background canvas, it would not be a valid move. So let's save that, come back into Unity and see that in action. And now, as you can see, we can freely move around, but we're locked at the edge of the canvas. We can't go off. Alright, so next up is going to be to make it so you can scroll in and out, and we'll have that capped as well. So we'll write a scroll function. Autocorrect is killing me today. Scroll. Fine, I'll do it myself. Okay, so do a private void scroll. Awesome. Now float scroll equals input dot get axis mouse scroll wheel. That will get us the input from the scroll wheel itself. Then vector 3 scroll movement equals. Now just suspend your disbelief for a minute here, because there's some random values in here that just took a little bit of trial and error to get right. So transform.forward times scroll times 1000 times scroll speed times time dot delta time. Awesome. That's our movement direction. Now if check valid scroll, and we'll once again put in the new position. So transform.position plus our movement vector. And if that output's true, then we will transform.translate scroll movement in the world space. Sweet. Now let's go ahead and write check valid scroll. So I'm pretty confident that code will work. Private bool check valid scroll. And we once again want to pass in the new position of the camera. So we're going to go bool valid move equals false. We'll assume that it's not a valid move to start. Excuse me, we'll assume that it is a valid move. That makes more sense. Valid move. So we're assuming it's a valid move to start. Then if new position dot y is less than min y, or new position dot y is greater than max y, then it is not a valid move because it's outside of our parameters. So let me save that up real quick. And we'll jump back over to Unity. Awesome. So we can scroll in a certain amount, then it locks us out, and we can move around on the edges, and that is going to do it. That is one completed camera controller that is dynamically clamped. So I'm sure some of you are wondering why I did this using raycasts and not something simpler like just clamping its X and Z, Y values. Now the reason is the method I use makes it way more dynamic. As long as your camera starts off pointing at what you want it to point at, you are guaranteed that this is going to work in any scene you throw it in. In our game, Time Walk Tower Defense, we have a whole bunch of different levels with varying parameters, and this makes it so we can easily just slap down the camera and know it's going to work without having to fine-tune all the values. Alright, I hope you guys found some good value in that, and I hope it can apply to your projects. If you enjoyed the tutorial and want to see more, drop a comment down below. As always, like, comment, subscribe, hit the bell, all that good stuff. And go wishlist Time Walk Tower Defense on Steam if you want to see when it releases. It really helps us out. We really appreciate it. And as always, game on.